Hello students, welcome to class 11 physics. In this video, we are going to solve the numericals of textbook illustration of chapter 5 laws of motion. So illustration number 8. A mass of 4 kg rests on a horizontal plane. The plane is gradually inclined at an angle theta is equals to 15 degree. With the horizontal, the mass just begins to slide. What is the coefficient of the static friction between the block and the surface? So your what is given, mass is given, the angle that the incline is making with the horizontal, that is also given, that is theta equals to 15 degree. And here we need to find the coefficient of the static friction. So first of all, let us see the free body diagram. Over here there is an inclined plane on which the mass is there. So the forces that are acting on this object, let us see that it will be weight in downward direction, which is equals to mg. The normal force by the surface, which is n. Here the static friction that is provided by the surface, that is Fs, because the object is sliding down, so the friction applied will be in the upward direction. Now because the mg is in this direction, we need to see the components. So this mg makes an angle theta with this vector, so that becomes the cos component. So this becomes mg cos theta, and the other vector which is perpendicular to that, that is the mg sin theta. So this is the free body diagram. Now let us see this. Force acting on the block and their component are shown in the figure. For equilibrium of the block, mg sin theta is equals to fs, because we can see over here mg sin theta is in this direction, fs is in opposite direction. So we can write mg sin theta is equals to fs, and here mg cos theta, that is in this direction, and normal force that is in opposite direction. So we can write mg cos theta is equals to n. So by taking the ratios of this equation 1 and equation 2, we get mg sin theta upon mg cos theta upon mg cos theta equals to fs upon n. Here mg gets cancelled and sin theta upon cos theta becomes tan theta, and on right hand side equation we are having fs upon n. So when theta increases, tan theta also increases, hence magnitude of fs will increase up to certain limit. Now here for theta is equals to theta maximum, frictional force become maximum fs. So from the equation 3 we can write tan theta max equals to fs max upon mu n. So here we know fs equals to mu s n. So this equation can be written as mu s n upon n, where n gets cancelled. So we are having tan theta max equals to mu s. So here theta is equals to 15 degree, so tan 15 degree equals to mu s, and tan 15 degree value is 0.2679. So when we round off that, we get its value as 0.27. So mu s is equals to 0.27, that is the coefficient of the static friction is 0.27. So students, you may note down this numerical. Now illustration number 9. What is the acceleration of the block and trolley system shown in the figure? If the coefficient of kinetic friction between the trolley and the surface is 0.04, what is the tension in the spring? Take g equals to 10 meter per second square and neglect the mass of the string. So here, as you can see in the figure, there is a trolley having weight 20 kg and there is a block over here. Its weight is its mass is 3 kg. So here the forces that are acting, here the trolley will be in this direction and it is tied with the help of the string. So tension is prevailing in this direction, which takes the object in that direction, and frictional force, that is the kinetic friction force, will be working in the opposite direction. When we see this, the tension that is prevailing in the upward direction, and because the object is moving in downwards, right, its mass is 3 kg and g that is taken as 10, its weight is taken as 30, that is mg. W equals to mg, here mass is 3, g is 10, so it will be 30 Newton. So weight will be in downward direction, its value is 30 Newton. Now acceleration of both block will be free body diagram of 3 kg. So we have seen for the block, tension is in upward direction and weight is in downward direction. And for the trolley, tension is towards the right hand side, whereas kinetic friction is towards the left hand side. In figure B, by Newton's second law of motion, we can write mg minus t equals to me, because here mg, let us take the resultant force, that is mg in downward direction, and plus minus t because it is in opposite direction, equals to the external force. So it can be written as mg minus t equals to force that is equals to me. So mg minus t equals to ma. So here mg, that is 30, minus t equals to mass, that is 3, because here we are talking about the block. So 3 into a. Now for trolley, let us see the equation. For trolley, we can say the total force, that is tension T, that is in right hand direction, plus kinetic friction, that is in opposite direction, that is equals to the resultant force. So we can write T minus Fk equals to force, that is me, but here we are taking mass of the trolley into acceleration. So the equation now becomes T minus Fk equals to me. Now kinetic friction is coefficient of the kinetic friction into the normal force. So it can be written as T minus mu kn equals to capital M, that is mass of the trolley is 20. So 20 A. Here normal mass, that is equals to the weight. So we can write capital M G. T minus mu k mg equals to 20 A. Let us put the value of kinetic coefficient of the kinetic friction, mass of the trolley, as well as g. So we get T minus 0.04 into 20 into 10 equals to 20 A. So it becomes T minus 8 equals to 20 A. So we got these two equations, equation 1 and equation 2. So adding that to equation, we get 30 minus 8 equals to 23A. 22 equals to 23A and A equals to 22 by 23. Its value is 0.9565. When we round off that, we get equivalent to 0.96. Now we need to find the tension. So putting the value of A either in equation 1 or equation 2, we can write 30 minus T equals to 3A. Taking T as the subject, that is on the opposite side, we get 30 minus 3A equals to T. Put the value of A, which is equals to 0.96. So it will be 30 minus 3 into 0.96 equals to 30 minus 2.88, which is equals to 27.12 Newton. So value of the tension that is prevailing in the string is 27.12 Newton. So students, you may copy down this numerical. Now let us solve the 10th illustration. A cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius 3 meter. That means a cyclist is moving in a circular path and its radius is equals to 3 meter. Without reducing the speed, that means speed is constant. The coefficient of static friction between the tires and the road is 0.1, that is mu s is equals to 0.1. Will the cyclist slip while taking the turn? So first of all, let us see the data. Here we have radius equals to 3 meter, mu s, that is the coefficient of static friction, as 0.1. Then speed is taken as 18 km per hour, converting that into meter per second. So instead of kilometer, let us write 1000 upon hour. Instead of hour, we can write 3600 second. So calculating this, we get 5 meter per second. And the maximum safe speed on a level circular track that we have already derived, that is equals to Vmax equals to mu s rg and under root, that is under root mu s rg. Now putting the values of mu s, r and g, we get under root 0.1 into 3 into 9.8. Its value is under root 2.94. When we solve this, we get 1.71464. Rounding off, we get Vmax equals to 1.714 meter per second. So here the cyclist speed, that is the maximum speed of it, should be 1.714 meter per second. If the speed of the cyclist is greater than this speed, then he will slip off from the path. So students, you may note down this numerical.